A skeptical look at STEM shortage numbers. STEM shortages are alleged shortages of STEM workers. STEM stands for science, technology, engineering, and mathematics. So in principle, it refers to scientists, engineers, and especially the last few years, computer scientists, software engineers, and programmers. STEM shortage claims date back a long ways. In fact, some people have found examples of it before World War II, but they've been common since the late 1940s after World War II. And even though there were a lot of people working in STEM jobs during World War II, there was the Manhattan Project with atomic weapons, numerous aerospace projects like the B-29 bomber. Many of the weapons in World War II were very high tech at the time. The development of military radars, penicillin. There were just a lot of these high-tech engineering and science projects during World War II, and they laid off a lot of people. Nonetheless, employers and politicians and other people nonetheless were claiming that there were shortages of scientists and engineers back in the 40s and 50s, especially after Sputnik in 1957, when the Soviet Union caught the United States off guard. They set up the first satellite. Sputnik 2 was actually large enough to carry a nuclear weapon, which was more significant. The original Sputnik was about the size of a basketball. The point of all this is there was actually even a really big panic about the United States being somehow short on scientists and engineers after Sputnik. These things were mostly not true back then. They've evolved since the end of the Cold War, and they're now mostly about computers, electronics, and especially the last few years, software engineering, people who write computer code, which is actually where the vast majority of STEM students end up. So you might get a degree in physics or some other field, but there really aren't that many jobs in a lot of STEM fields, a lot of types of engineering. So all sorts of people with training in a wide range of scientific fields and engineering fields end up as software engineers or programmers. And nonetheless, despite that, there are numerous claims and allegations that either there is a shortage or there's imminently going to be a shortage. So here in this video and in the article I published on my website, I'm going to take a critical look at the STEM shortage numbers and what are the actual numbers behind this that drive it. So I'll give an example, a recent example of one of these claims. This is from Emerson. It's an electronics company in Missouri. They've been around for a long time, and they've been putting out a survey for the last couple of years. It's basically an opinion survey that people think that there is a crisis. Well, the evidence of it is fairly weak when you actually look at it. So it's kind of an amazing title actually here. Emerson survey, 2 in 5 Americans believe the STEM worker shortage is at crisis levels. Now it's been at crisis levels according to these kind of reports and news articles since the 1940s. But in fact, 2 in 5 is a minority. It's 40% of Americans. It means a large majority, 60% of Americans who were surveyed by Emerson, and the questions are often very loaded in these surveys to try to get you to give the answer that they want to hear, which is there's a crisis. Even so, 60% said no crisis. But let's look at some of what they say. While the survey found students today are twice as likely to study STEM fields compared to their parents, the number of roles requiring STEM expertise is growing at a rate that exceeds current workforce capacity. In manufacturing alone, the National Association of Manufacturing and Deloitte predict the U.S. will need to fill about 3.5 million jobs by 2025, yet as many as 2 million of these jobs may go unfilled due to the difficulty of finding people with the skills in demand. This paragraph is a very typical STEM shortage claim. It's nothing new. Things like this have been said for many decades every year, mostly either directly by employers like Emerson or by think tanks or other organizations that are funded by employers. So let's go back and what's the reality here? I mean, it sounds like an absolute disaster coming, and it always has since the 1940s, since Sputnik, but the disaster never comes. Typically, these claims are tied in with claims that our education system is terrible, particularly in science and math. So in these things, you never hear about the Bronx High School of Science or Stuyvesant in New York City. You never hear about elite public schools, the Robert Gun School here in Palo Alto. You don't hear about these private schools like Phillips Exeter Academy. That's where Mark Zuckerberg went for his senior year. A lot of these elite private schools have very good science and math programs, as well as many public schools, typically in more expensive areas or special magnet schools like the Bronx High School of Science or Stuyvesant in New York. Well, what's the reality? What are we actually doing? Well, let's take a look at students who pass one of the advanced placement calculus exams. So this is a very good proxy for our good qualified STEM students at the K through 12 level. So these exams are typically taken by most students 11th or 12th grade. Some people do actually take them earlier. There are 5 scores. You can get a 1 and a 2. That's basically you failed. 3, 4, and 5 start, so 3 is qualified and 5 is very, very good performance. So getting a 3 on one of these exams is a great accomplishment. Calculus is a very demanding course. It's difficult to learn calculus. It's something which is used, and good to know, in most STEM degrees and professions. Almost all STEM students, certainly the good ones, the top ones, will take calculus, and it's to your advantage to know calculus. To have a really deep understanding of statistics, which almost everybody uses now in science and engineering, you need to have some understanding of calculus and how the statistical methods were derived. So the point is, calculus is a really good thing to take. It's taken by people across, they're electrical engineers or chemists or physicists or computer scientists, or a lot of people take calculus. It's a very good proxy for the good students who have mastered the subjects. It requires strong quantitative skills, strong logical skills. If you can do well in calculus, you can write computer programs, you can do a lot of other stuff. And today, most people that are taking advanced placement calculus and actually scoring well have computers and actually have at least basic, high school level computer skills, even if they've never taken something like AP Computer Science. So it's a very good proxy and way to look at it. It's also a standardized test provided by the College Board. So whether you're at the Bronx High School of Science or you're at some school in rural Kentucky or East Palo Alto or whatever, wherever you are, the grade means the same thing. There's no question about the quality of the grading or the certifications from institutions, teachers. That's really a big issue with a lot of STEM college degrees. People will say, oh, well, it's the wrong degree, or it's from a mediocre school, things like that. Well, this is standardized testing, so these students are comparable regardless of where they live, race, creed, color, religion. It's all screened out by this kind of standardized testing. So this is a table that I put together of the number of students who have passed, have gotten 3 or better on the AB exam, the BC exam, and both, for every year from 2002 to 2016. And this information is available on the College Board website. They've archived their data all the way back to about 1997. Some of the early reports from like the 90s are kind of hard to interpret. So I started at 2002 where it's clear and worked my way forward to 2016. So what you find here is that, for example, in 2016, 284,000 students scored 3 or higher on the AP Calculus exam, either the AB or the more advanced BC exam. So about 180,000 students scored 3 or better on the AB, and about 100,000 scored 3 or better on the BC exam. So BC Calculus is in fact comparable to a full 1-year advanced calculus course, introductory calculus course at a really good school, someplace like Caltech or MIT or any kind of good university or college that has a really strong math program. That's what BC Calculus is. All told, from 2002 to 2016, 3 million, let me repeat that, 3 million students scored 3 or better on either the AB or the BC Calculus. The AB was about 2 million and the BC was slightly less than 1 million. So total is 3 million students just in the last 14 years. Now, I wasn't able to find earlier data, though I'm sure the College Board has it. So I went ahead and I fit a model showing some exponential growth, which actually is a good model of this data, to try to figure out how many people took it before I have data, before 2002. You can see the model fits very well. It has a coefficient of determination of 0.988. That means 98.8% of the variation in the model, in the data is explained by the model. So the exponential model seems like a pretty good model. And what we find is that about 2 million people probably took the exam between 1970 and 2002 when that data starts in my analysis. So all told, about 5 million people have taken the exam and scored a passing or better grade, the 3, 4, or 5. And 3 is considered qualified. So it means that you understand calculus. You have learned either the AB calculus or the BC calculus, and you're considered competent and proficient in that. You may not be perfect like some of the people who score 5 literally score perfectly on the exams, but you're good. And it's an accomplishment to take calculus and successfully master it. So this model, in fact, predicts that between 2016, and I'll explain why I using 2016. Um, and 2026, the next 10 years roughly, there will be about 4.2 million students who are going to take the AP Calculus exam, either the A, B, or BC, and score 3 or higher. So this is a estimate of how many STEM students will come out of the system. If you were just to take the 280,000 that took the exam and passed in 2016, and you just extrapolate that linearly without any growth, and you would expect it to grow with the population, if not more, then you're in fact looking at 2.8 million students, not the 4.2 million predicted by my model, but 2.8 million taking the course and passing between 2016 and 2026. And I choose the period 2016 to 2026 to match it with a projection from the Bureau of Labor Statistics, probably more reliable than Emerson, but from 2016 to 2026. It's their most recent projection on their website. So the point of all this is the U.S. produces many qualified STEM students at the K through 12 level. So we have a lot of good schools or good programs within schools that produce many millions of students. And these students are good enough that they pass these standardized tests for calculus, which is a difficult course, and one which is basically required or good to learn for almost all STEM professions, all STEM degrees. So let's take a look at what the Bureau of Labor Statistics says. And they're often what is being quoted. Emerson is quoting like the National Association of Manufacturers, which is probably less reliable. But the United States Bureau of Labor Statistics, that's the federal government. It's often considered a reliable, authoritative source. Now they say that they expect between 2016 and 2026 that there will be an additional 853,600 jobs in the STEM field. So this is new jobs on top of ones that exist. Well, that's considerably less than the 4 million students predicted by my model. It's much less than the 2.8 million students predicted by simply extrapolating the current rate. So we're producing, in some sense, qualified calculus students, people who pass the AP exams, at 284,000 per year, probably more this year. More probably it's gone up since 2016. We don't have the numbers yet. Now, the BLS estimates there are 7.3 million science and engineering workers in 2016. So keep in mind, the U.S. has over 310 million people. I think it's closer to 320 million people. But out of those, only 7.3 million, or thereabouts, are actually STEM workers. There are not that many scientists and engineers. These are mostly our top students. And that's one of the things that's deceptive about these numbers. The people that go into this tend to be the people who score very well, the people who, in fact, take AP calculus and pass, or even get fives, people who score, in the 700s in SATs, things like that. So it's projected to increase to 8.2 million. That's an 11% increase by 2026 over this 10-year period. So what you can see is it appears that we have tons of these students, the STEM students, who are taking AP Calculus. They'll easily cover the 853,000 or so new jobs. Now, the Bureau of Labor Statistics also predicts that about 1.5 million scientists and engineers will leave the labor force, exit the labor force is their buzz phrase, due to retirement, death, and caring for family members who are getting sick or often getting older is why they get sick. And this is plausible if the science and engineering workforce has ages that are uniformly distributed between 22 and 65, your typical retirement age. In that case, we would expect a lot of people to retire and some to pass away, about a quarter of the current labor force of 7.3 million people. However, if we put that number, 1.8 million plus 800,000 or so together, we get 2.6 million openings. These are the new jobs that have been created, plus replacing the people who retire, die, or have to take care of family members. So that actually, even if we only keep going at the 284,000 per year rate at the K through 12 level, these people who pass the AP Calculus, which is probably most of the STEM students at the K through 12 level who are capable of and will go on and be, actual STEM workers, hey, we've got enough right there. And of course, my model is predicting continual growth. We expect at least growth with the population. Now, it appears that more people are taking AP Calculus than just population growth to account for the curve that we see. But regardless, it's pretty clear that there are going to be enough people to cover these things. Now, at this point, the Bureau of Labor Statistics does something rather weird. They introduce what they call occupational transfers, which appears to mean basically people who, for some strange reason, leave their STEM job, which is supposedly, high-paying job, very desirable. There's a shortage, right? But nonetheless, and here's the language from a report from the Congressional Research Service. It says, so in addition to the people who retired, died, etc., in addition to the growth of jobs from new business that's being projected, which is about put together about 2.2, 2.5 million. In addition, BLS projects that there will be an additional 3.7 million openings created by occupational transfers in science and engineering positions during this period. That is, workers in science and engineering occupations who leave their jobs to take jobs in different occupations, science and engineering or not science and engineering. So that's 3.7 million. That's over half the 7.3 million people total working in science and engineering, according to the BLS, are going to have what they are calling an occupational transfer, which is weird bureaucratic jargon. Now, this author here actually proceeds to qualify this with a lot of stuff. And as he says, the BLS projections do not include data that allow for a quantitative analysis of how many new workers, those not in the labor market in 2016, will be required for openings created by job growth, labor force exits, and occupational transfers, as there is no detail to how many of the S&E, the science and engineering openings, are expected to be filled by workers transferring into these openings from science and engineering occupations and from non-science and engineering occupations. Blah, blah, blah. It's really wordy. So it's really unclear what these occupational transfers are supposed to be. So the Bureau of Labor Statistics appears, at least if you interpret it one way, to be claiming that an astonishing 3.7 million STEM workers, over half the people currently employed, will somehow leave the STEM professions, thus creating a need for many more STEM workers than would actually be produced by the AP Calculus process through K through 12. That we could say those people are kind of qualified by virtue of passing AP Calculus. Well, what does that mean? Are there really that many people leaving or not? Pretty weird. And this is typical that you see these really confusing, bizarre statistics in claiming STEM shortages or that there's going to be one. Now, it's very clear, again, if you look just at the new jobs that you might expect based on typical economic growth, that's the 800,000 or so, and the 1.5 million or so people who will leave as they get older, they retire, they die, maybe they have to take care of a loved one who's getting old and sick, that kind of thing. Take those, that's totally covered. There's plenty of people for that coming through calculus, plenty of K through 12 STEM students. So it's only with these mysterious occupational transfers that you could ever claim anything like a shortage. And they're not defining what they're talking about at all. It's as the comments I read from the Congressional Research Service basically admit. Okay, so what is this? I could speculate. It's worth noting the U.S. Census a few years ago found that there were this is in 2012, it's a little bit earlier, that's why the number is smaller. There were 5.3 million STEM workers. And astonishingly, there were 12.1 million STEM degree holders in the United States. So less than half of people with STEM degrees are actually working in STEM fields. There are many more STEM degree holders than students who took AP Calculus and scored 3 on the exam. So what does one make of all that? Well, that goes a bit beyond what is the scope of this article or what I'm talking about right now, and I may discuss that in future videos and articles. It's worth noting that if you take what the BLS seems to be saying at face value, they are assuming an extremely high turnover rate in STEM workers, with at least 50% dropping out or maybe pushed out somehow in only 10 years. Remember, this is a projection from 2016 to 2026, a 10-year period of time, to get that 3.7 million people to somehow leave or transfer to some non-STEM profession or whatever they're talking about. That's an extremely high turnover rate. So I will leave that with you. Is that a reasonable assumption? And what does that mean? Suppose you really face that kind of a turnover rate if you take a STEM job. You get a STEM degree, you put all that effort into getting a bachelor's degree or a more advanced degree in computer science or software engineering, and you're looking at 50% chance, more than a 50% chance of having to leave and move to some other profession. One would hope that what you learn in college, these kind of things, you're going to do it until you're retiring at 65. So that's something to think about. Now, I think probably this occupational transfer thing is very questionable from a scientific, scholarly point of view, but we don't know what it is. And this is kind of typical of these numbers. They're full of these strange definitions and other things. So the conclusion I want to leave the audience with, is if you look at students who take AP Calculus, who take either the AB Calculus exam or the BC Calculus exam and get 3, which is considered qualified or passing, or better, K through 12 schools in the United States are producing large numbers of highly qualified STEM students. Those students are by themselves, I mean, remember, there have been about 5 million of them probably up until 2016. Just those students are nearly sufficient to fill the existing STEM jobs. It would take some more people. Some people who come in and take calculus take STEM courses in college. Undoubtedly, there's some people who lose interest, but nonetheless, it's basically pretty close to the number of jobs out there. In fact, we know that there are many more STEM degree holders, over twice as many as there are taking these calculus courses and as there are actually jobs. So those students that we can track with the AP Calculus at the K through 12 level are already nearly able to fill these jobs without any guest workers on these visas like the H-1B, not even considering people who don't take AP Calculus and later get into the STEM fields in college or even later in life. Computer programming in particular is something that you can get into from almost any background. It's learned by doing. You can get a computer. They cost next to nothing these days. The programs like Python, and there's Python code in my article, it's something anybody can learn. I mean, you can set up Python for free on your computer and learn. So there's lots of ability to come into these fields beyond these students who take these very demanding calculus courses and so on. So the bottom line is the United States K through 12 school system is producing very large numbers of students who are highly qualified and who are taking and passing a very demanding college level courses which are necessary or very prudent to take in almost any STEM profession. So this article also includes the actual code, Python code that was used for fitting the data, and the numbers I derived from the College Board archives data for the number of people. And that's further down here in the appendix if you want to do that. So again, since this is a YouTube video, please like the video. Please give me comments. Let me know what's good, what you'd like improved, where it could be better. I'll try to answer questions if I can. I am extremely busy with both personal matters and my business, but I do try to answer any comments or emails or questions that I receive. So the warning here is obviously that you should be very skeptical of STEM shortage numbers, especially from STEM employers. These numbers are often very exaggerated, and the actual numbers that we have from the College Board show that our K through 12 system is producing large numbers of highly qualified, hardworking K through 12 students.